Hello, my name is Tim Radatz. I work for the Discovery Farms programs in Minnesota and Wisconsin. Today, I'm going to talk about the past data collection we've done of surface water runoff and tile drainage and what we are learning from that data, and also get into some new and upcoming studies and the exciting potential of those. Discovery Farms is a farmer-led water quality research and educational program. We focus on farmer leadership and water quality discussions, credible research of surface water runoff and tile drainage, and then also communicating the results. We want to communicate what we're finding throughout our project areas. We collect edge of field surface runoff and tile flow data 365 days a year with automated sampling equipment. And we're collecting a number of different variables at the edge of field with our monitoring sites, whether that be weather in terms of rainfall, the amount of rainfall, intensity of that rainfall, temperature, soil moisture, soil temperature, all things like that. We also collect the amount of flow in terms of gallons that leave that field either through surface runoff or tile drainage, and then sample that flow for sediment or nitrogen and phosphorus, or sediment and nitrogen and phosphorus. And what's really important is we monitor in both conditions that you see here in the picture on the left, that really wintertime runoff, which is very important for our upper Midwest climate, unfortunately, or fortunately. And also in that, as we move into the growing season when soils thaw and we have more runoff or rainfall driven runoff. We collect that flow volume. It's a very important measurement for us because we can multiply that flow volume times concentration and calculate losses on a pounds per acre basis. Our program is built on partnerships. Partnerships are essential to Discovery Farms, and farmers are key. Whether it be the participating farmers in these projects or farmers that sit on our steering committee and actually select projects that we go to and set up monitoring and review our results. Partnerships on the monitoring end are also essential. In Minnesota, we partner with the Minnesota Department of Agriculture, and these partnerships are critical for us generating a high quality data source that we can use in our education and outreach programs. We also partner with local partners across Minnesota, and they're the ones that actually go out and collect samples and maintain our monitoring sites to, again, ensure that we have that high quality data source that we can then use. We've worked throughout Minnesota and Wisconsin over the past 10 to 20 years. In Minnesota, we've ranged all the way from southeast Minnesota up to northwest Minnesota. And that's been a fantastic thing for me to get to travel around all these different landscapes. Minnesota is very diverse in terms of landscapes, but also farming enterprises. So we've worked with hog farms, we've worked with dairies, we've worked with turkey, poultry facilities, and then also grain facilities. And we've worked in the hilly regions of southeast Minnesota up into the flat as a pancake Red River Valley. And it's very interesting to collect data in these different farming systems and different environments and see what we can learn. So first thing I talk about a lot of times in my presentations is runoff happens. Everybody knows that famous bumper sticker, right? No, but runoff does happen. Runoff was measured in 150 out of 151 years of surface runoff data throughout our Discovery Farms data set and 90 out of 90 years of our tile flow data set. So we happen to live in a climate and in landscapes where we have excess water, and there's times throughout that year, or times throughout the year, where that excess water is going to leave the landscape. That just is a fact of where we live. So while we might not be able to prevent runoff, we do have control over what's in that runoff in terms of sediment and nutrients based on the way we manage and implement practices on our fields. Soil loss mostly occurs with surface runoff. This is a chart looking at the annual soil loss on a pounds per acre basis. Each one of these dots is a site year throughout our Discovery Farms data set. So this is across farming enterprises, across regions and landscapes. But you can see here that we have much higher surface or soil loss movement through surface runoff compared to tile flow. In tile, we just don't move that much sediment. If you want to focus on anything in this graph, I would focus on this gray bar here. This is the middle 50% of our data set. So 33 to 375 pounds per acre is in general where we expect most of our sites to come in at in terms of soil loss. And to put this in context, this is anywhere around 5-gallon pails of soil per acre on an annual basis. So a lot of our sites are doing really well in terms of soil loss. We do have sites on the higher end here where we really need to look into ways to reduce those soil loss numbers to bring them down into more acceptable levels. If we're looking at how to manage soil loss, it's really imperative to understand the timing of soil loss. 76% of our soil loss that we've monitored in our programs has been in the May, June, and July time period. And what this is, it's that combination of vulnerable soils, right? Limited soil cover until our annual crop establishes a canopy. So a combination of that and increasingly intense storm events. So we can reduce soil losses by providing protection during this critical time period, whether that would be from increased residue that protects the soil surface, whether that be from a growing cover crop that protects the soil surface from those impacts of the raindrops. Anything that we're providing increased protection of the soil surface during this time period is going to reduce our losses. However, the level of protection needed is site specific, right? If we live in Southeast Minnesota, our level of protection needed might be very different compared to Northwest Minnesota. So in order to assess where you're at in terms of how much protection you need, we always recommend driving around during that May, June, and July time period. Soil loss is a very visual thing, right? So if you drive around and we can see sediment covering our plants, sediment in corners of the fields, rills moving down our hillsides, things like that, and we see that year after year, every other year, or every third year, we probably need to look at our level of soil protection during that May, June, July period and see if we can't change something within either our tillage system or our crops being grown to provide more protection during that time. Phosphorus loss is similar to soil loss in terms that it mainly moves with surface runoff. A typical range for surface runoff is anywhere from 0.5 pound per acre to 2 pounds per acre. And what we've found throughout our data set is that 50% of that phosphorus has been in the particulate form, so attached to soil particles, and 50% has been in the dissolved form. So these things are really critical to understand when we're looking at ways to mitigate phosphorus movement off of our landscape. There's different practices that we need to be concerned with when we're looking at particulate phosphorus compared to that dissolved phosphorus fraction. And in our area of the upper Midwest, because we have that snowmelt time period, and that snowmelt time period is typically when we see most of our dissolved phosphorus losses, we need to blend our practices so that we can manage both that particulate phosphorus fraction and that dissolved phosphorus fraction. And a little bit on how to work on this blending. If we split our data set up into no-till sites on the left here and tillage sites on the right, and this is a graph of annual soil loss, we can see our no-till systems really knock out the top part of our soil loss, really take out those extreme events and provide a lot of protection in terms of soil. So you'd think maybe, well, that our total phosphorus would kind of mirror those results. Unfortunately, they don't. The total phosphorus is very similar between the no-till sites and the tillage sites. And the reason behind this was the increased level of dissolved phosphorus that we see in our no-till sites compared to our till sites. And we think this is due to a few different reasons, one being an increased residue amount in our no-till systems. And when we have snowmelt runoff interacting with increased residue amounts, we can have higher dissolved phosphorus losses, but also an increased soil test P in the upper inch of the soil profile. So a stratified soil test phosphorus in those no-till sites contributes to higher dissolved phosphorus losses in the surface water runoff. So this kind of points back to matching your tillage system or your soil disturbance with your landscape. For areas that we can incorporate our phosphorus from manure and fertilizer, we should be doing that to reduce our risk of dissolved phosphorus loss. But it's important to remember that we need to really assess the level of soil disturbance that we're doing so that we're not creating so much soil disturbance that we're increasing our risk of soil loss. It's really a fine balance there. If we move on to nitrogen loss, it mainly occurs with tile flow, and nearly all the nitrogen in tile systems is in the nitrate form. For tile flow, we see ranges anywhere from 8 to 37 pounds per acre is pretty typical for what we're seeing. The amount of nitrogen loss in tile systems is heavily dependent on the amount of flow. So as we get more flow, we get more nitrate movement through those tile systems. This is a graph of all of our tile sites looking at tile flow on an annual basis on the x-axis, and then nitrate losses on an annual basis in pounds per acre on the y-axis. So as our flow goes up, so does our nitrate loss pretty proportionately. On average, it's about 4 pounds per acre nitrate for every inch of drainage. And a lot of times, as I talked about before, we have limited impact on the amount of flow or runoff that we can see off of our field. So what do we have control over? What we do have control over is our concentration of nitrate in that soil profile. So the amount of nitrate available to move with drainage water if drainage water is occurring. So if we're at 6 inches of a drainage, loss can be tripled just by a simple increase in concentration. If we move from 10 to 20 milligrams per liter of nitrate up to 40 to 50 milligrams per liter of nitrate, we can really have an impact on our total nitrogen losses. So what impacts nitrate concentrations in the soil profile? This is where we're looking at cropping types or rotations, different species that you're planting, nitrogen fertilizer and manure management programs, specifically looking at rate and timing are very important when we're looking at managing that nitrate concentration in our soil profile. And this is a helpful chart that I talk about a lot from Purdue Extension that they put together looking at nitrogen concentrations in tile lines, and kind of give some handy benchmark levels that we've been using in some of our Discovery Farms work. When we're looking at nitrogen concentrations less than 5, these are typically our native grassland. CRP alfalfa is a good one for that concentration. As we move into 5 to 10, this is row crop production without fertilizer, row crop production with a winter crop, so a cover crop. What we're shooting here for is if we're in that 10 to 20 range, if we're just a corn soybean type rotation with no cover crop. This, if you're in that 10 to 20 parts per million or milligrams per liter, we think you're doing a very good job of nitrogen management, meaning we're applying at the right rates and the right times where crops are going to use that nitrogen in the most efficient form. Where we focus on is our sites where we have above 20 parts per million. As we get up into the 30s and 40s and 50s, those are sites we need to look at our nitrogen management, either from fertilizer or manure. Are we applying at excess rates at timings that aren't applicable for our climate and our crop being grown? Do we need to look at adding a cover crop to try to reduce some of those levels? Those are all things we're looking at investigating. So in a wrap, to wrap up this first part of my presentation, keys to reduce soil and nutrient losses: control soil loss by using appropriate level of soil protection, specifically protecting that soil during that May-June time period before our annual crops fully canopy. For phosphorus, first part of phosphorus would be controlling our soil losses. We can control that particulate phosphorus. But after we get our soil losses controlled, consider our timing and placement of phosphorus fertilizer and manure application to reduce that dissolved phosphorus fraction. If we can incorporate our fertilizer and manure and also time it in a way that it's not timed with a significant runoff event, we can lower that risk of dissolved phosphorus loss. Lastly, with nitrogen, consider timing and rate, crop rotation, cover crops, when we're looking to reduce the level of nitrogen movement through the soil profile and into our tile systems. So as we talk about what we have learned, I'm going to touch on a few exciting new projects that we're working on. Continuing work, we're really looking to assess the role of cover crops in surface water and tile drainage runoff and nutrient and sediment losses. And our site that we have set up to do this is in Redwood County, Minnesota. So western Minnesota, southern Minnesota. We have two sites on the same field, a north site and a south site, each around 10 acres in size, and both have tile drainage and surface runoff exiting the field at the same spot. So it's kind of a nice paired basin design looking at both surface and subsurface tile. So it started in 2017 and continued through the present. But 2017 through 2020, the north and the south sites were managed the same. So this is a corn soybean farm with limited tillage, a no-till beans, spring vertical till on the corn, fall anhydrous end source for the corn, and a cover crop was always flown on in August into either the soybean or the corn crop, with mixed results during those time periods. And in both basins were managed the same during this time period. But the change happened in August of 2020. The cover crop is still going to be flown on the north site, but not on the south site. And all other management variables will remain the same and consistent between the two sites. So the only real difference between this comparison is that cover crop that's flown on in August of each year. And we're hoping that he's tried a few different cover crop species with that flying on application with mixed results, has gotten in more into the cereal rye, and actually worked with his county to have that being allowed as part of his high fly mix, because he has much better luck with that cereal rye and wants something to come back in the springtime for that soil protection. So here's a picture from this past November looking at the established cover crop in the North Basin. So you see lots of corn residue here, and you can see some cereal rye poking through that corn residue. So on the North Basin, we have that situation. On the South Basin, a similar picture to this, just without that cover crop poking through. So over the past 3 years, or 3.5 years, we've worked on pairing these basins, and this is, we want to establish a relationship between the two and then change a practice to see if that practice has any impact on the relationship. So to do that, we plot up surface and tile runoff for the North Basin on the x-axis and the South Basin on the y-axis. And as we go, you can see that if it would follow this one-to-one relationship, that would mean we have equal amounts of runoff in the North and South Basin. As we move above that line, that means that we have more runoff and tile flow on the South Basin compared to the North Basin. If it was on the bottom side of that one-to-one relationship, we would have more flow in the north side than the south side. But So from our study from May 7, 2017 through September 2020, the south site had more flow in terms of surface water runoff and tile flow than the north site. And this was pretty consistent throughout the study period. If we're looking at soil loss, the north site was the winner in terms of this relationship, where the north site had more soil loss compared to the south site. Phosphorus loss, really close to that one-to-one relationship, meaning each basin was losing phosphorus at a consistent level throughout the study. And then finally, nitrate, nitrogen. Similar to the flow, we see higher nitrate nitrogen movement on the south site compared to the north site. So what are we going to do in terms of comparison now that one site's going to be getting cover crops and the other site is not? We're looking to shift that relationship between the north and south basins with cover crops. So are we going to see the same result in terms of the previous when everything was managed the same? That would indicate no impact due to the cover crops. Are we going to see a higher or similar nitrate loss on the south basin, but reduced on the north basin? That would indicate an improvement due to cover crops. And similarly, if the relationship goes the other way, we can document a decline if that happens. And I think based on other research that's being done, I think we have a really good chance to see an improvement in nitrate losses. Phosphorus is a little bit more tricky. I think we have a potential to improve the soil loss numbers as well with the cover crop. But we're really interested in what the phosphorus does in terms of, do we lose more dissolved phosphorus from our cover crop? Do we how does that relationship change with this change in practice? And all the while at the same time documenting yield impacts and highlighting management considerations for people that want to follow along and understand the impacts to their systems. Another one of our sites that is looking at the role of cover crops in this surface water runoff and tile drainage runoff in terms of sediment and nitrogen losses is our site in Wright County, Minnesota. This site is a little bit different setup. We don't have paired basins set up, but we have a long data set that we've been collecting since 2012. And so we first started out in 2012 with 3 years of corn silage. In 2015, peas and triticale were planted, harvested, and then alfalfa was established in that late summer of 2015. New tile was also installed in this field during that time frame, and then we had alfalfa for the past, or from 2016 through 2019. So as we get into that 2019 period, a change happened. They actually ended up selling their dairy cows and are switching to a different rotation that includes more covers and more limited tillage, more no-till and some single pass tillage instead of 2 to 3 tillage passes. So as we move into 20 was in rye into soybeans. It'll continue with a it'll continue with a winter wheat crop, and then a cover into corn with limited tillage, and the nutrient source is going to change a little bit too. So it'll be interesting to watch our different variables or water quality variables and how they are impacted by this change of system. Will we have beneficial changes to nitrate movement, phosphorus movement, soil loss? Those are all things we'll be monitoring with this site. So with that, thanks for your time. Have a great day.